All right, welcome back to my channel, everybody. So today I'm going to talk and walk you through Fortinet SD-WAN. So in this video, I'm going to walk you through Fortinet Secure SD-WAN, and I'm going to talk about two use cases and also demonstrate one use case within my lab environment. The first use case we'll talk about is the data center branch connectivity, and also the second one is application steering of critical services. Let's dive in. You're going to enjoy this video because you are going to dive into configurations of Fortinet SD-WAN from the hub to the branch and all that. Stay tuned. So we're going to talk about Fortinet SD-WAN, which is secure SD-WAN. And before we dive into the use cases on the screen, I would like to talk about a little bit about Fortinet SD-WAN, the device itself, and all that. On Fortigate Firewall, which is the next generation firewall, converges both the networking and security feature on one OS, which is the FortiOS. So what does this mean? It means that the firewall, which is the next generation firewall Fortigate device, has the capability to do networking and also do security on the same OS. So if you are running SD-WAN, or if you want to run SD-WAN, we can simply use the Fortigate device and leverage on the feature without additional maybe third party or any other devices combined to it. So which makes the deployment very seamless for users. So on the Fortigate device, you have SD-WAN feature, you have next generation firewall feature, you have advanced routing such as OSPF, BGP, RIP, policy routing, SD-WAN, all other advanced routing that are not that proprietary. Then Fortigate also serves as ZTNA app gateway for zero trust network access configuration and deployment. For managing multiple Fortigate devices, you want to use a FortiManager. So the FortiManager serves as orchestrator to be able to push configurations and policies to your Fortigate devices no matter where they are. You understand? So you can manage up to more than 2 or 3 Fortigates on a single pane of glass. That's the essence of the FortiManager. And in this video, I will walk you through how to do the configuration manually on each of those Fortigate device. And my next video will talk about how you can use FortiManager to deploy your configuration across board. Talking about SD-WAN, we know SD-WAN is software-defined WAN area network. It's like introducing intelligence to your WAN edge devices so that you can intelligently route traffic to the desired destination. So the first use case we are going to look at is the first use case we are going to look at is the data branch connectivity. The data branch connectivity talks about a customer or an enterprise with many branches or many sites, and those branches wants to access resources at the data center or resources at the head office. One of the beautiful thing, one of the traditional way of doing that before was that most organizations introduce what we know as MPLS link. So the MPLS link is able to create a form of network for the branches and data center so that users at at data center and users at each of these branches or regions can be able to access device resources at the HQ or the data center. But the challenge of that is that one, it was very costly for users to use, for customers and for organizations. And two, MPLS is not application aware, is not that intelligent. It's whatsoever you configure that you're going to get. So it's not intelligent to be able to learn and adapt to your network, to learn the applications that are within your network and prioritize those applications for you. So that's why we have the introduction of secure SD-WAN, which leverages on intelligence, based on the link performance, based on some of the performance SLA that you're going to put in place, the links performance, so to speak, like the latency, jitter, and packet loss. Based on this, the SD-WAN feature on the Fortigate is able to take a real-time performance of those links and use that to be able to decide where your traffic is going to go based on these destinations that you're going to put there. So looking at this branch, so each of this branch has, let's say, a broadband network, a DIA network, and MPLS link. So the beautiful aspect of SD-WAN is that you can combine multiple ISP links, be it broadband, DIA, MPLS, on a single box, and you can intelligently route your traffic to the data center or your HQ to be able to access resources, such that when a link is failing, let's say your MPLS link or your broadband link is lagging behind, SD-WAN can be able to, the FortiGate device can be able to leverage on the best performing link to be able to reach your destination and have access to those resources. So some terminologies that you would come across in SD-WAN is the underlay link and the overlay link. The underlay link the underlay link are just the link that are terminated directly on the FortiGate device. So each of the branches, like each of those branches, let's say the region 1 and region 2 and the headquarters, we have a FortiGate device as their edge. And at that edge, a link will be terminated, or two links or three links, depending on the architecture of that environment, will be terminated on those device. Let's say the broadband and the DIA link or the MPLS link, based on the design that is here, and that is known as the underlay link. If you have MPLS link directly terminated on the FortiGate, or a broadband link, or a DIA link, or an internet service provider link terminated on the FortiGate device, they are always known as the underlay link. The overlay link are the tunnels that you build. If you look at this design, you'll see the dashes, the line dashes. Those are the overlay link that are built using the underlay link to be able to create a tunnel directly to the headquarters or to the HQ or to the data center, so that the software behind a FortiGate there can be accessed. So the underlay link are what you're going to use and develop and create, so that users at this region will be able to access the device or the resources that you want to provide for them at the data center. And I'm going to demonstrate this in the lab using my two FortiGate device, and also simulate the two ISP the two ISP link that are terminated, and we'll be able to create an overlay link with those two one link, so that we can be able to have access to the resources online. Then we'll also test that when one link fails, maybe one link goes down, or the performance SLA or the threshold for each of those links has been exceeded. We'll see how SD-WAN will fail over to the second link, so that there won't be any form of overdue interruption in accessing resources at the data center. Then that's for the first use case, which I'm going to demonstrate here. Then the second one is the application steering of critical services. In talking about this use case speaks to some of the critical applications that most organizations or enterprises have, and they don't want any form of downtime for those applications. So organizations or enterprises combine two or three ISP together, so that users behind it can leverage on those ISPs, and they will have a good user experience having access to the internet. The combination of this doesn't really guarantee good network performance until you begin to set your priority, like a quality of services and application steering and all that. So what most people or organizations do is that either of those services or either of the ISP link that you've terminated on the device, you can dedicate one based on the best performance of the link, such that you can give priority to your critical services, whether your cloud applications and your collaboration tools like Teams, Zoom, G Suite, Salesforce, and all that. And you can define an SD-WAN rule that this link should take priority in such a way that a link, let's say you have a DIA link that is always good and it has good bandwidth and all that. You can dedicate that for those applications. Then every other applications or traffic can now follow suit. So when you are defining your SLA, performance SLA based on packet loss, jitter, and latency, you have these services in view, such that when one link fails, the other link can take over. So your applications will not suffer. So they can easily, use a link and judiciously use a link. And when that link is degrading, the second one can take over. Depending on what you really want to do. But the point here is that you can prioritize applications, whether your cloud applications, your collaboration tools, and all that, so that users can have a very good user experience while transversing the internet. And one of the beautiful things about the Fortigate device is that like it is application aware. You understand, more than 5,000 application signatures were integrated to this, so you don't have to define them using maybe your public IP addresses and all that. You can easily pick those signatures or from the SD-WAN rule and define your SD-WAN rule based on the performance you're looking, and there will be a smooth communication to the internet. So I think we've spoken about this. Then the next thing is that we'll delve into the demo for this use case one. So we'll have one site, we have a hub, and we have a branch. So at the hub, there will be two ISP links. We'll simulate two ISP links. Then at the branch, we'll simulate two ISP links, and we'll also simulate users trying to access a link behind a resource behind the link, and we'll simulate the failure of one link, and we'll see how SD-WAN will switch over to the second one. Stay tuned, don't go yet. So here is our Fortigate devices. Like I mentioned, I'll be implementing the SD-WAN manually on the Fortigate devices. My next video, will be using the Forti Manager to implement them. Using Forti Manager makes it very easy, but for simple explanation so that you can understand how the very rudiment of the implementation without using Forti Manager, because Forti Manager can serve as automations, can build policies, templates for your SD-WANs. But just to grow granular, so we just do it manually on the devices. So this Fortigate represents the hub device, while this branch device represents the branch Fortigate device that will be at the edge of each of those offices. So at the hub here, we have the interface. Coming to network interface, you see the LAN network here describes the network that is belonging to the servers or applications or internal users that most of the branch users will be having access to in terms of access to applications and all that. So this is the network for the for the servers, for anything that the branch users are trying to have access to, which is internal to the hub device. Then we have the ISP link, which is our WAN link. This can serve as an ISP internet link for users to be able to have access to the internet and all that. Then we have the WAN link, the MPLS link. These two combinations to serve. We use these two combinations of link to build an overlay link or overlay tunnel, like I mentioned in the previous video, so that the tunnel will be built from the branch, which is the overlay link, to the headquarter for easy access of applications using that tunnel. And the tunnel is secure, uses IPSEC protocols for security and all that. So same thing here at the branch. We have the LAN network, which our branch users would be on, which is the network that most of our devices at the branches will be on. Then we have the ISP network. So the internet ISP and the MPLS link. So the beautiful thing is that with this design, um, the users at the branch, because they have access to internet, they can easily, have access to internet directly at the branch without having to leverage on the hub or the data center device before they have access to the internet. And they can do that securely, leveraging on the policies and security profiles that we are going to define for them to have access to the internet. So they don't necessarily need to, channel their traffic, internet traffic, to the hub for them to have access to the internet securely. So that's a beautiful aspect of Fortinet, whereby we make it a secure SD-WAN. So building your tunnels, your SD-WAN template and all that, users don't necessarily need to leverage on the internet resources at the hub to have access to the internet, because at the branch you have terminated an internet link here for your users. The users can be able to build tunnel and overlay tunnels with the ISP link and the MPLS, and can also be able to use that ISP link to have access to the internet securely using our SD-WAN profile, SD-WAN profile and security profile rules. So let's start with the hub device. So we are going to do this granularly, and let's go to. So the first thing is that we want to build a tunnel with the. Let's start with the internet device. So you come to SD-WAN, VPN, then IPSEC tunnels. Creating IPSEC tunnels is very simple on Fortigate device using the wizard. You just have to understand what you're doing to be able to do that. Then come to tunnels, IPSEC tunnel, then create. Then let's name it um, one via internet link. So the model for the SD-WAN or tunnel we are creating is hub and spoke model, hub and spoke, whereby the device at the headquarter or the branch will serve as the hub. So I think we have more character here. Let's use hub internet link, hub one. Then we define this as the hub. Then click on next. The incoming interface will be the ISP link interface. We have to use, you can use a pre-shared key or signature, but let's use a pre-shared key. Define our pre-shared key. Then now this tunnel IP is the IP address you are going to give each of the tunnels you're creating. So let's say, let me bring up this device. So looking at this, let's say we are using, let's say this green link is our internet link and this yellow link is our MPLS link. So these two links, these two green and yellow link have an IP address at both ends. So this tunnel as well. So creating a tunnel, which is the dash 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 you see beneath each of those links is the overlay link you're creating. So this link here at this point here, we have an IP address that is in the same network with this IP address, which is called the tunnel IP address. Tunnel IP address. So where you're creating this as well, to have an IP address here, also have the remote IP address. So we are going to give each of those tunnels the IP address so that we can be able to use them. Then we can define this as 10.10. The tunnel IP is the IP address of the tunnel of the hub, while the remote IP is the IP address of the tunnel of the branch that we're going to create for that link. So we have 10.10.2.1, 10.10.2.2. I think we should use, you can go ahead with it. So /24, you can use /30, you can use /24 or slash any subnet mask, depending on the number of sites you're going to provision. I just leave it as 24 because with this I can add more sites to this network so that they can share, they can be in the same urban spoke mesh. Then so the VPN SD-WAN, Fortinet SD-WAN leverages more on BGP advanced routing. So with this, you can, in this wizard, it will help you define everything that you don't have to configurations, but using the wizard, you can be able to, define it as you're configuring the tunnels. So it's going to use the BGP advanced routing, and we're going to define our parameters here. So 65,000, which is the local autonomous service. Then local interface here will be the LAN interface, which is the internal network that users wants to have access to. Then the spoke IP here, let's give it .2, which will be the IP address that will be on the tunnel of the branch. So create next. So now being able to create the link. So looking at this, so being able to create the VPN tunnel on the hub Fortigate. And if you look at this easy spoke configuration key, so with the new feature on Fortigate, you can easily copy this code and paste it in the configuration of the branch, and all the configuration needed to be able to build the tunnel to this hub will be created for you on the branch. So let's go straight to the branch interface. At the branch here, we come to VPN IPSEC tunnels. So let's create IPSEC tunnel. Then let's name it spoke one int, which is the internet. Then we have urban spoke. So definitely the role of this device will be spoke. So you can see the key, which is the code we copied. We just paste it here and we apply. So once you apply, click next. So the outgoing interface on this branch will be our one ISP1. Then the pre-shared key that we defined the other time. Make sure that the pre-shared key is the same. So you click next. Then you can see click next. Your local AS can be anything, but I'm going to give it 65,000. Then the local interface, which is the internal network of your branch device. Then you click next and you create the tunnel. So once you create the tunnel, you can show tunnel list. So we can see in no time our tunnels will be created. So now our tunnels has been created. You can see the two tunnels are up from the hub and from the spoke. So SD-WAN mostly is always from the branch. So what do I mean? So at the branch mostly is where you configure your SD-WAN for your branch users, because your branch users are the one trying to access the application at the hub. So looking at this diagram again, so we have that. So at this space, as this edge is where you create your SD-WAN, which I'm going to show you, so that these two links can be combined together to be able to access the resources at the behind the FortiGate at the HQ. So coming to this place, let's start here so that when we create the second tunnel, we'll just add it to the SD-WAN interface. So in creating SD-WAN, we can have SD-WAN created for both the underlay and for the overlay. So for the underlay, which are the links that are directly terminated on the ISP. So assuming you have two ISP links here, which are for internet access and all that, you can combine the two together to be able to form um, a navigate of SD-WAN so that your users can be able to have access to the internet. But the focus here is for the underlay tunnels, SD-WAN for the underlay tunnels, which we are going to do. Then coming to, so we won't be able to create an SD-WAN with them unless we take um we take so looking at this, looking at this 1 minute. So looking at this, we need to delete these firewall policies that has been created for us. Why? Because if we want to include this tunnel in an SD-WAN zone, which we are going to create, we need to remove it from SD-WAN because we won't be able to do that because it has already been referenced in a firewall policy. So if you come here and you say SD-WAN, which is under network, and you try to create an SD-WAN member, you won't see that tunnel here because it has already been used in a firewall policy. So it's always good to set up your SD-WAN first before defining your firewall policies and all that. So what we'll do is I will come to the firewall policies, then we'll delete this. So if you come to your network and you come to BGP, you will see that your BGP has neighbors. You see coming here, network, BGP. See, the neighborship has been formed, and if you see view routing monitor, you will see that this has been formed by the two um, devices. So I think we need to define a router ID for each of these sites. So here we'll come to BGP, then define this router ID for this, apply, and go to the hub, go to the hub. Let's define the router ID. So I'm just using the local IP address of the LAN to define the BGP router ID on both ends. So I think this helps. So now on our branch, don't forget we want to configure SD-WAN, and we've deleted the firewall policies. Yeah, then you come to network, SD-WAN, then SD-WAN zone. Let's create an SD-WAN zone, then we'll name it overlay. Click OK. So we have an overlay zone here. Then let's create a member. So here you come to see this member is here. Then you put it in an overlay zone. You don't need to define a gateway because the SD-WAN will automatically do that for us. Create OK. So now we have our SD-WAN zone defined. Then we'll come to performance SLA. So we want to define our performance SLA. So from the branch to the hub, we want to be able to reach this network. Then we'll use this IP address on the Fortigate as a probing server for us, or depending on whatsoever you have internally that you want to be probing for network performance for SD-WAN. So for this, I'm going to use the interface of the Fortigate. Let's say FGT up. Then we define the server, which is 174. Then I will specify the interface here. The interface here going to the hub side is the spoke one VPN that we just created one. Then click OK. So if you come back here and see the performance SLA, you will see that the performance SLA of this, the latency is 2.61 milliseconds, then the jitter is 3.26 milliseconds. We can go back and set our SLA threshold. That the threshold we want for this latency, the latency threshold we want could be maybe 20 milliseconds. Then jitter can be 5, or depending on the capacity of, or the what's it called again? There's one word I want to use. The resilience, yeah, depending on the resilience of your applications and all that. So we set the latency to 20 ms, which means that if this link exceed 20 milliseconds by latency, milliseconds latency, Fortigate would look for another available link to to transfer your traffic if it's better than this 20 milliseconds that we set, which is the threshold. You understand? Then the link status shows that at every 500 milliseconds, Fortigate will be checking the link to ensure that the link is still active, and if there's failure for 5 multiple times within this interval, then the link will fail over to the best one. This is set. This is very important because to avoid network flapping in your environment. Then we'll click OK. So we have 2.64 ms and we have 3 ms jitter, and packet loss is 0. Then on our firewall policy, we want to set our firewall policy from the branch to the headquarters. So we can say that from this end, we say access to hub network. So we have incoming interface as the LAN, which is resident to the branch site. Then the outgoing interface will be the overlay. Don't forget, we have only just integrated one link, and we're just using that to set up, so that when we go back to set up the second link, we just add it to this overlay zone that we've created. Then the source can be all, and destination can be the IP address of the hub network. So when you come to the hub network, so we have this, you can copy the LAN IP address of the hub network, or any of the network you want to have access to based on your configuration of network. So don't forget, hub network starts from 0, which is 192.168.74.0/24. Then we click OK. So you select it as your destination, then service all. Then so here you can also define your security profiles. That's why we call it Secure SD-WAN. You can leverage the security ETM feature of your Fortigate on this. You can define your antivirus protection profiles, check them, depending on what you want and all that. You can also do web filtering, DNS filtering, application control, and all that. This also is useful for users that are trying to traverse the internet network, which we are going to discuss in the next video. So let's click OK. So this policy is for users going from the branch LAN network to the hub device. So we want to also create a rule that is coming from the hub network to the branch. So we'll now create a universal rule from branch. Then incoming interface will be our overlay zone, outgoing will be the LAN, then source will be the hub network that we define. Source, you understand. Destination can be all into your network, or you can be specific based on what you want users to have access to in your environment. Then your log allow traffic, you can set that and click OK. So we have two what's it called, two firewall policies from the traffic from the hub and traffic to the hub to this. And one more thing you want to do is that on the network, you go to the SD-WAN rule, go to SD-WAN rule. So we have our SD-WAN performance SLA that has been set. Then you go to SD-WAN rule, then you create. So you can say hub access to hub network or servers. So from here, you can the source address can be all, or you can define the the network or the IP address or any users that you want them to have access from this SD-WAN rule. So then destination can be hub network. The hub network can be, you can define specific servers that you want this rule to match, so that when this rule is being used, is only for that specific server. But for the sake of this demo, we'll just use the hub network. Then go to the outgoing interface selection strategy. So we have different strategy to be able to use our overlay links. You can select manual. Manual means that you don't want any interference. Once you select manual, the Fortigate device or the SD-WAN feature continue to use that device irrespective of the performance of the link until the link goes down, like totally. If the link is degrading in performance, maybe latency, jitter, and packet loss, if it's on manual, the Fortigate will still continually use this. But if you put it as best quality, using best quality, you cannot define your measured SLA. So based on the performance SLA that we defined the other time. So in doing this, best quality means that looking at the quality criteria, you can use latency, jitter, and perfect. We are using latency, which means that if this link exceed the threshold that we set the other time, which is 20 ms, that means that Fortigate will look for a better link that is not breaching our threshold, which we are going to configure. We are going to configure the second link soon. So we can also select the zone preference, which is the overlay soon. So that means the policy here is that for SD-WAN policies from everybody from the branch to the hub network, you understand? Or you can also be specific, like I mentioned. Then you click OK. So now we have our SD-WAN rule created, and if you look at this, currently our traffic is being passed through using the this. So want to try and create the second link over the MPLS underlay link, so that you can have two links here for our SD-WAN rule. So coming to your hub device, so we have coming to the VPN, come to IPSEC tunnel, then create IPSEC tunnel, then hub and spoke. This has to be hub. Then we have hub MPLS link. Then next, now this one will be our MPLS link. So we're using our MPLS link now for the second underlay link. Then click on next. So now the tunnel also the tunnel IP address, we are also going to give the tunnel IP address for the MPLS overlay tunnels that we are creating. So let's say 10.10.1.3 and 10.10.3 10.10.3.1 and 10.10.3.2/24. So let's just copy this, then click on next. So we can have this as 65,000 BGP parameters. Then local interface will be your LAN. Then what else? Then this will be .2, which is the remote, the spoke that we want to configure next. Then click on next, and this has been created. So like the other time we should copy this spoke as well and come to the branch Fortigate device. Coming to the VPN, we create IPSEC tunnel, create the tunnel again, then spoke 1 MPLS, then come to spoke, then paste the easy configuration key, which is very easy to deploy, then Fortinet. So looking at this, this automatically match our MPLS interface to this, which is very sweet. Then we have the tunnel IP and the remote. Next, you can have these parameters, local interface as LAN, then next, create. Now, we've created the second tunnel. So let's see if the second tunnel is going to come up. Now the second tunnel is up. So if you check your BGP network, you see that we have two neighbors. And when you come here, you see they are fully established, 2.1 and 3.1. Then because we've already configured our SD-WAN right from time, so one thing we want to do is that we want to add this spoke 1 MPLS to the overlay zone. So we have to delete it, the firewall policy that the IPSEC wizard created for us. Then come to network, come to SD-WAN. Then under this, we can create member because we already have the zone. Then come to MPLS 1, then select your zone as overlay, and okay. So if you look at this, we have the overlay, zone, and the two links are there. Coming to your performance SLA. So the performance SLA as well, you are going to add the interface to this performance SLA so that two of them can be probed to the same destination and can be able to check the best performing link. So if you look at this, we have the two links are up, and one has best latency based on what we have here. One is 1.60 milliseconds, the other is 2.83 milliseconds. One has a good jitter, 1.41 and 4.41 ms. So we're having a real-time performance check on this link, you get, and which is very important. So you can, with this, you can even know which of your link are bad, which of your link are out. This give you enough visibility into the status of your links and all that. So coming to your SD-WAN rule, because we've already created an SD-WAN rule to this site, we just need to add our link to it, the second link to this rule, so that the two links will be the same. So if you look at this rule, you can see that based on what we have here, look at this check mark. It means that currently our traffic is to the hub, is being used, is transversing over the spoke one overlay, you get. So because if you look at the spoke one overlay, you see that the spoke one overlay latency is very low compared to the MPLS overlay. So that's why we have this being used for now. So coming to your hub, because when you created the IPSEC tunnels and all that, at the hub side, the wizard has created all the firewall policies that you need. With this as well, you can do ADDPN, which means that if you have multiple sites, multiple branches, branch one, branch two, branch three, and you want them to communicate within themselves. ADVPN do it in such a way that they don't have to, before they communicate, they don't have to go through the hub for them to communicate. There will be a short path created between the two sites, between branch one and branch two, for that communication to happen. And that's what we've been able to create here. And all these things are very good. So if you look at the BGP network, you'll see that the network is fine and all that. You don't necessarily have to create an SD-WAN policy or rule or add the data center, because you're only using that from the branch. So if you have multiple branches, you have branch one, branch two, branch three, whatsoever you do here is also what you are going to do at those branches, which makes the Forti manager very useful in such a way that you don't have to configure them one after the other. So if you build a template here for branch one, you can use that same template for all your branches, and within few minutes you can bring like 50 branches up that will connect to your hub, and they'll be able to have access to the devices or servers or applications at the data center. So now let's test uh, uh, um, what we've done. So one of the things we want to do now is that, because we don't really have a server behind this device, but we want to be able to ping this IP address from the branch. So what we'll do is that, coming to here, let's first see whether we can ping. So at the branch we execute ping, so we're able to reach it from the branch, but we want to be able to do it from the source. So we want to be able to be sure that from this LAN, if any user is on this LAN, is able to pass through the network to the hub center. So we can source from the internal LAN of the branch. So execute ping option source, then put the IP address. Then we can now say, let's ping this that want to be execute ping. So let's do a trace route to our device. Let's see what device will execute trace route. This, let's see where we're passing through to the hub, to the LAN. So okay, this is not showing us, but okay, let's say execute ping. Let's do a continuous ping. Let's source from here. Let's do execute ping option. That's a ping. Let's say 5,000. Repeat count. So let's ping. Let's continually. Okay, sorry. Let's continually ping. Execute ping options. Repeat count 5,000. This will ensure continuous pinging. So let's source from the LAN interface of our device, which is 192.168.19.129. So now let's ping let's ping the remote site 192.168.74.131. So we have a continuous pinging going on. Then what we want to do is to turn off the current link that is working, to see how it's going to work. So this is currently working. So let's go to the branch. So interface. Currently we're using this. Let's just disable. So let's check if our continuous ping is still going on. So now you see we have an alteration first. So we see that there's a continuous pinging at this end. So if you check, so if you come and check let's check our path. Let's see, come to SD-WAN rule. You see that this link is down, and we are using the MPLS link. You see that this link is down, and currently what we're using is this link. Come to SD-WAN rule, see that this link is down, then we're using the MPLS link. So now we see that traffic is passing through the second link. Yep. So the next video we'll do the second one, which is the application steering. Uh, thank you.